Okay, chemistry. I want to talk a little bit about Dalton's atomic theory. You've probably come across this before, and I'd be surprised if you haven't seen something like this before. But it's really a beautiful explanation and example of what a scientific theory is, and how this can sort of change but still be correct. So we have two core things that we sort of strive for in science. So one is to describe things in natural laws. So these are usually mathematical equations. So if this happens, then this is going to happen. And it's usually something that's highly mathematical, so it is effective prediction. So a lot of physics is all about natural laws that we describe. Scientific theories are trickier. So scientific theories are things that are intended to explain why something happens, right? So natural law says this will happen, so it describes that it happens, but why it happens is really tricky. And so that's what scientific theories do, is they give you an explanation for how something works. So Dalton's atomic theory is an explanation for really how chemistry works and how largely the world around us works at the very small level. And Dalton's atomic theory, he came up with these four, postulates, I guess you would say. That one, each element is composed of extremely small particles, that all atoms give off of a given element are identical. Atoms of one element cannot be changed to atoms of a different element. And compounds are made by combining elements together. So he had this beautiful idea that chemistry is just the shuffling around of atoms. Well, yeah, it's a great idea. Was he right? Was he right? Well, no. No, he got a lot of stuff wrong, but it's still a very useful theory and a very useful way to help us understand and explain the world around. So we've made it more sophisticated, right? So first thing he said, are atoms indivisible? He said they were, but we know they're made up of protons, neutrons, and electrons, and you can break up protons and neutrons into quarks and into smaller things. So yeah, he wasn't exactly right, but is his theory wrong? Is it a bad explanation for chemistry? No, it still works really well, and it's a great thought process and explanation for how things work. He said all atoms of an element are identical, and you'll soon learn why that's not true. But there are things that we're going to work on related to radioactivity. He said one element cannot be turned into another element. Well, we can, right? If you have a fusion experiment going on, or if you have a collider, you can convert one element into another element. It's not really common. It's not really part of everyday chemistry that we know about. So, was he wrong? No. Some details need to be changed, and so the atomic theory has been revised, and its original state, it was well stated for the time, and it's been made more sophisticated since then, but it's still a great explanation for how chemistry works. And so this is a good example of scientific theory. So scientific theories are really hard things to come up with. There are a very limited number of scientific theories. Right? So it's difficult to come up with a really good and solid and well-supported explanation for things. So did you know that the plates of the continents are getting further away from each other, right? So we can measure this, right? So we can measure the continental drift. We can see that Europe is getting further away from the United States by about like 2 centimeters a year, right? So that's an observation. Why is that happening? Well, somebody had to come up with the idea of plate tectonics and the theory of plate tectonics, which explains why continents are drifting apart from each other. We've never seen a plate, so we can't drill down that far. But it's a wonderful explanation for how something works and why something behaves the way that it does. So scientific theory is a really helpful thing. So a lot of support for these things. Dalton's atomic theory has some interesting experiments that supported it. So you may have come across these before. So Rutherford's, there's a video I'll suggest you watch. It's kind of entertaining to see somebody make up an experiment. But we've learned more about the structure of the atom by doing a bunch of experiments and discovering that, we can break it down. It is mostly empty space. Go figure. the amount of space that the protons and neutrons and electrons take up is really tiny compared to the size of the atom, right? So things spread out a bit. And so Rutherford found with his gold foil experiment, again, there's a reconstruction. It's entertaining to watch. And the Millikan's oil drop experiment is really interesting to be able to identify the mass and charge of an electron. So really interesting and painfully tedious experiment they did. So anyway, a bunch of experiments. I encourage you to read about those. It's kind of interesting. The text has them. I'm not going to ask you to memorize or even know the names of these guys, but I hope you get across the idea that natural law is really helpful and really important and really useful things. Not so hard to find. There are a lot of those described in the world around us. Scientific theories, really difficult to find, and they're well supported. So scientific theories are supported by lots of evidence. It's the best explanation for the data. And they do change a little bit. So fundamentally, Dalton's theory was wrong, but it's still a great way, and we've revised it and made it more sophisticated so it adapts to the time like all theories. Anyway, I hope that's helpful, and we'll talk to you soon. Bye.